Good afternoon, everyone, and welcome to our annual SheCanEngineer STEM webinar. Today, we're celebrating International Women in Engineering Day with yourselves and 5 very special guests who are going to share with us some of the amazing work that they do at their day jobs. You'll have experienced science, technology, and maths through your studies, so we're here today for the next hour or so to give you an insight into the world of engineering. You'll be hearing about some of the novel and creative ways our engineers are solving the problems that the rest of us hadn't quite considered. We'll be hearing from our 5 speakers shortly, but we also need you, our students who have joined the webinar today. We need you for your insights and your questions. So as the speakers are presenting, feel free to type in your question. We'll have time at the end to put your questions to the speakers, and as an added little incentive for you, we'll be giving a £20 gift voucher to the student who asks the best question today. So please make sure it is clear which speaker your question is addressed to. It can be a technical question based on the talks you hear today, or something about their careers, how they got into their field, anything you like. So now it gives me great pleasure to introduce you to our first speaker for the day, Anusha Shah. Anusha is a director of Resilient Cities at Arcadis, and she is also a visiting professor at King's College London. She is on track to take up a rather inspiring role in 2023 as president of the Institution of Civil Engineers. Now, this part in particular made me smile. She would be the first person from an ethnic minority background to hold that position in the 200 years of the institution's history. She enjoys mentoring young engineers, especially women, as she feels our world needs more female leaders to tackle global challenges. Welcome to the webinar, Anusha.
Thanks for that kind introduction, Myra. Good afternoon, everyone. I'm delighted to be here with you all this afternoon. I can talk on the subject all day, but I've been given 7 minutes, so I'll try my best. So whatever we see around us has been built by engineers of the past, from the beautiful parks to the fascinating sewage system in London to every piece of infrastructure what we use. We as engineers of present continue to improve the day-to-day quality of life for the society. And in the future, we are amazingly positioned to tackle humanity's biggest challenges. Our world is changing rapidly. As you all know, climate change is here, and we are already facing it through flooding, water scarcity, and heat waves around the world. We have other connected challenges such as urban poverty, migration of people due to wars mostly, but will increase now due to climate change. We already have climate refugees in the world. Water scarcity isn't a story about developing countries only. We can face severe shortage of water in the country in a decade or so. And COVID-19 has added another layer of complexity. Challenge, but it taught us some great lessons too. The biggest lesson is stay prepared for the unknown. For this preparation, we need engineers in the leadership position more than ever before to solve these problems. As Barack Obama rightly said, we are the first generation to feel the impact of climate change and the last to be able to do anything about it. Recognizing the importance of building a fairer, healthier, greener, and a happier world, the United Nations came up with a plan, a blueprint of 17 goals with targets to achieve by 2030. As a civil engineer, when I go through these goals, I can see we can influence and work on each of them with other professions. That's because we work on a range of interrelated subjects in the built environment. Climate change, like COVID-19, knows no borders. It can impact anyone, anywhere. So our response to this also has to be by bringing together diverse engineers and professionals to solve the challenge. It's not all doom and gloom. As this image, I really like this image, as this image shows, in the process of tackling climate change, we can actually engineer a better world, create cities and places that are livable, green, healthy, happy, and more importantly, that leave no one behind. We have a choice. We can carry on with business as usual and end up with a barren, unhappy world, or we pull together, take up engineering, work with other professions, and build in harmony with nature. Luckily, we are at an exciting time as engineers. We have a brilliant enabler, digital technology. We can use for good, for example, use drones to plant trees or tools that help us measure, track, and monitor carbon. But we can't do this unless we have engineers from all backgrounds working together, bringing their unique insights and perspectives, and them in turn working with other professionals like psychologists, sociologists, so that we understand communities better and design the infrastructure for them. For example, if Apple had a woman on their design team, they would not have come up with earphones that get entangled with long earrings. You have a fantastic opportunity of joining a profession where you can build cities that work for everyone, regardless of abilities, gender, or backgrounds. And let me tell you, it's not always construction that you get involved in as an engineer. You can be a planner, designer, communications lead, heading stakeholder engagement, and yet be an engineer. There's a huge variety of roles for the future engineer. And more than ever before, we need women to be designing for women and everyone. I can't stress this enough. You have a huge opportunity to join a profession that has exciting plans, building with nature. For example, green roofs, as you see on the image, that serve several purposes for a building, absorbing rainwater, providing insulation, creating a habitat for wildlife, decreasing stress of the people, and just aesthetically pleasing landscape, because one of the biggest challenges is biodiversity loss as well, and this can help and give us multifunctional infrastructure and help us to mitigate the heat island effect as well. So in the end, I would say we at Arcadis, the company I work for, would love to hear from you, as we have a program where we encourage students to see the real world projects, and you have an opportunity to see what we do on a day-to-day basis. I really like the quote from the managing director of International Monetary Fund, Kristalina Georgina. She said, "The best memorial we can build for those who lost their lives in the pandemic is a greener, smarter, and a fairer world." And I tell you, by joining engineering, you have a huge opportunity to be part of a vibrant profession that will build a fairer, greener, resilient, and a happier world for the future generations. Now, who wouldn't want to join us? Thanks very much.
Thank you very much, Anusha. Next up, we have Georgina Seeley. Since graduating from Newcastle University with a master's degree in civil and environmental engineering, Georgina has worked in the water industry for over 20 years. She's had a range of management roles and now heads up the Thames Water Project Definition Team. There she is responsible for briefing all of the Thames Water's engineering projects ready for design and construction. Georgina is a fellow of the Institution of Civil Engineers and is also a mom of 2 lovely children. Welcome, Georgina.
Thank you. Thank you for that introduction. Today I'm here on behalf of the water industry. I thought it was important to let you know that during these last few months, I wanted to share that all my colleagues have continued to work, many from home, but as we are all considered to be key workers to maintain water supplies and treat wastewater during the coronavirus pandemic, it's been quite an interesting time. Today I will share more on how we maintain our supplies and plan for the future, whilst ensuring we protect the environment. This plan shows how large the Thames Water area is. Every day we supply around 2,600 million litres of tap water, and if you consider a 1 litre bottle of water that you may have with you, we supply 2,600 million of those every day. We also remove and treat 4 billion litres of wastewater for our 15 million customers every day. On this map, you can also see we have education centres, recreation sites and wetland areas where you can explore and find out more on how we protect the environment. During my career so far as an engineer at Thames Water, I have been lucky to work on projects to build and maintain a variety of assets. Given the area and number of people we serve, these assets can be huge. At the top left-hand corner there, you can see the inside of a service reservoir, a large purpose-built underground box, basically. I've been inside quite a few of these, and they are vast. In some cases, we even have things like golf courses built over the top of them. At the top middle there, you can see Beckton Sewage Treatment Works. This is the largest sewage treatment works in Europe. And if you can just see at the bottom of the right-hand corner of that picture, you can see that's the River Thames to give you an idea of the scale of it. The top right-hand corner there is a picture to show our control room to remotely monitor and manage the network and mains and treatment sites across our large area. We have 31,000 kilometres of water pipe network and over 100,000 kilometres of sewer network to look after. In the bottom middle there, you can see a picture of one of the raw water reservoirs we also maintain. We have 30 One of my first jobs was to do some design work for maintaining partial embankment on that reservoir, as you can see, which is Farmore Reservoir. I remember walking all the way around it and thinking how lucky I was to be able to work in such an environment. These are really important man-made structures which we need to maintain. And others you might see is if you're on a plane and you're flying into Heathrow, you will see some of these either side of the M25. On some you can even sail them, they're so large. On one particular reservoir, the QE2, we've installed Europe's largest floating solar panels so that we can get some of the power supply for our own plants. And on the bottom right-hand corner there, I've also been a project manager for a big tunnel project, an extension of a ring main to provide water around London, which is 2.5 meters diameter. It's very deep underground. That one there is a lot larger, but it shows some of the assets and the scale of what we look after. With all of these assets to maintain, we've not just got to look after them for now, but we also need to think about the future. A lot are already at their maximum usage, and we know London is growing so fast. As you can see from this graph here, the population of our region is predicted to grow by 2.1 million people by 2045. With an estimated 1.3 million houses that will need to be built. We need to ensure that we can continue to serve all these customers and deal with issues such as climate change, ageing infrastructure, new regulations, and how the markets might change. But it's not just about population growth. Over the last few years, we've really seen severe weather, and this has impacted our area. We still need to maintain supplies throughout. Water resources are becoming scarcer, and we need to plan ahead to ensure we have enough for everyone. You can see here some of the images of things we've had to deal with, including the beast from the east and droughts. We also need to consider the impact of others, including contamination to our networks by wrong connections or inappropriate use. You may have heard in the news about fatbergs. These are really unpleasant, and they've hit the news quite a bit recently for the size and scale of how much they can block up and cause problems, particularly in cities. So this is just a gentle reminder to only flush the 3 P's down the toilet: pee, poo and paper. The government has set out a framework we are following to plan for the future and ensure we are resilient to some of the issues I've raised. These are called the 4 R's. The first one is redundancy, ensuring we are not relying on one single site or one particular asset to supply customers or treat sewage. Then there's reliability, ensuring that everything we do look after is maintained and can be used for as long as possible. Resistance is to ensure we can use them through if there are any external risks, such as the big freeze or power cuts. And response and recovery. If things do go wrong, we need to ensure we have plans in place to get back to normal as quickly as possible. When planning for the future, we need to be sensitive to the current environment, working with it and ensuring we leave it ideally in a better way than it was before. This is an image of some of the work currently going ahead in London. Enormous engineering work, but underground, and for most people, they are unaware of the scale of work going on underneath them. You can see here the depths we can work at compared to the river and also the tube there on the right-hand side. I have learnt there is a huge variety of roles within the water industry, and they support your career and professional development. We are proud to provide an essential service, particularly in these challenging times, and we are keen to maintain this for the future. There are lots of opportunities for new ways of thinking to ensure we continue to protect the environment, and best of all, whilst embracing the best of science and engineering. Thanks for listening, and I'll now hand over.
Thank you so much, Georgina. That was really interesting. Now we can go over to Laura Huang. Laura is an aerospace design engineer at BAE Systems. She's recently won awards for her achievements in the sector, and she dedicates a lot of her time to volunteering with engineering councils and committees. Now, this is particularly interesting. At secondary school, Laura had never heard of engineering until her teachers spotted her passion for maths and science and encouraged her to follow the discipline. She graduated with a systems engineering degree and has been working in the aerospace sector ever since. Laura was saying earlier her favourite thing about her job is getting to work with so many different people on so many interesting technologies. Welcome, Laura.
Thanks, Myra. Hi, everyone. So as Myra said, I work as an aerospace design engineer. My current role is actually within program integration engineering, which basically means that I make sure that all of the different parts of something that we design for the customer work together to create something that actually works properly, effectively and safely. As Myra said, I do a lot of other roles outside of my work with the Royal Aeronautical Society, and roller derby takes up my spare time. And as you can see from this slide, I struggle to take serious photos of myself. So for those of you who may not have heard of aerospace engineering, it is basically all things to do with airplanes and space. It's not just the mechanics and the aerodynamics though, so what you might associate aerospace with on the left, my part of aerospace looks more like the right-hand side. So my background is in cockpit design and training systems design. There's me in a cockpit, there's a simulator there, and some of you might recognize that cockpit on the bottom right-hand side as the Crew Dragon cockpit that's from SpaceX. So, for one of our biggest challenges, in my opinion, is keeping up with technological advancements. Even though the aerospace industry seems to be at the forefront of technology, technology actually advances so quickly and it's so readily available nowadays that it is hard to keep up. For example, VR headsets. How many of you have used one? They're so readily available. You can buy them for use at home to play video games, for example. When you do play video games, computer games, the visual graphics are so realistic now. Compare that to the games that we had like 10 years ago, for example. They're not, the graphics, they don't look as realistic. The mobile phones that you have in your pockets now have over 100,000 times more processing power than the Apollo 11 computer that helped send humans to the moon in 1969, which is pretty powerful stuff. All of that in this tiny little thing that you have in your hand. So the generation that we're starting to train now, for example, have, like yourselves, have grown up with technology, and the traditional methods like paper-based training no longer cuts it. So with all the technology available, like with the visual graphics, for example, on the VR headsets, means that simulated flying becomes a much better option. The Royal Aeronautical Society surveyed its young members asking the question, what are the top 3 issues that you think aerospace and aviation have to address to remain attractive to the next generation? And by far the biggest answer was sustainability. So by training pilots to fly in simulators rather than real-life flying, we can reduce our carbon footprint and become more sustainable. However, with all these technological advancements comes complexity. So we as engineers have to make all the technology work together, like fitting pieces together in a puzzle. And the more technology there is, the more advanced there is, the more pieces there are, and the more complex something becomes. Then it becomes a puzzle that we need help solving. And so we have to reach out to others who have the skills and expertise to help us. For me, this is one of the most important tools we need to be able to face these challenges, and that's collaboration. These are 2 examples of collaboration within the aerospace industry at the moment. Team Tempest on the left is a collaboration with large aerospace companies in the UK, who actually are competitors with each other, as well as working together to design and develop the next generation military jet. And a couple of weeks ago, how many of you tuned in to watch history being made with the USA sending humans into space for the first time in nearly a decade? So NASA teamed up with SpaceX, who are a private company. NASA is part of the US government. So this is the first time a private company sent astronauts to the International Space Station, which is quite an amazing feat. NASA couldn't have done this without SpaceX, and SpaceX couldn't have done this without NASA. So each brought their own unique capabilities. So that launch on the 30th of May gives us an insight to what the future holds within the aerospace industry. The Falcon 9 launcher and the Dragon spacecraft have been designed to be reusable, which means commercial space travel becomes more viable. What do I mean by that? That means that in the future, within your lifetime, you can go into space for a holiday. And that's a thought I'll leave you with. Thank you very much.
Thank you so much, Laura. That's a really nice thought to be left with. Our next speaker today is Zoe Hazeman, Vice President of Global Sustainability at Jacobs. Zoe's background is in sustainable engineering, but she started off with a degree in environmental science from the University of Manchester. Now, with 20 years of experience in the field of sustainability across a range of sectors and locations, including San Francisco, she's carved out a brilliant career in construction and engineering. She was telling me that engineering has allowed her to create a brighter future for society, and that's what she loves about it. Later this month, she'll be volunteering as a judge at a nationwide university-level competition with the charity Engineers Without Borders. You'll see now she's very passionate about working with students and introducing them to careers in STEM. Welcome, Zoe.
Thanks, Myra, and hello, everybody. I am delighted to talk to you all about an area that I've been learning more about recently in my role, and I find it fascinating, so I'm hoping you all will too. Nature has been around us for over 3.8 billion years, and over this time, it's created ecosystems that are efficient, effective, and sustainable. As engineers, we're now looking more to nature to solve challenges and create solutions that are effective and sustainable for future generations. The engineers of tomorrow can find innovation all around us in nature. But what is it that we need to solve for? Engineers are some of the best placed professionals to help solve for the world's greatest challenges. Anusha introduced these earlier in her presentation, but it's worth reinforcing what, as a planet and society, we need to be solving for every day. These global challenges are well summarised here in the United Nations Sustainable Development Goals, or the SDGs as we call them, and span the most pressing economic, environmental and social issues of our time, from poverty to access to clean water, from reduced inequalities to climate action. This is our roadmap for the future, no matter what you're studying now and what you eventually go on to do in your careers. Without progress across these 17 global goals, our planet and its people cannot thrive. So as engineers, it's no longer good enough to think about one-dimensional problem statements. For example, build a bridge from point A to point B for a client. We need to be asking why and creating solutions that add value across the board. For example, how can that bridge improve air quality? Will the bridge create increased access to jobs and economic development for all of society? And do we really actually need the bridge, or could we solve the problem by using the existing infrastructure in a different way? It is clear we cannot keep going the way we are if we want to have a sustainable future. So we must innovate and find solutions that mean economic progress while respecting our planet and society. But innovation doesn't have to be about shiny new inventions, and it doesn't always have to be about technology. As engineers, this is our mission, to create solutions that work on every level. Innovation is about thinking differently, and the answers might just be all around us already. Biomimicry might be the answer, or some of it at least. In this context, and put in its simplest terms, biomimicry is copying nature, either in its shape or form, or in its processes or relationships, to solve engineering challenges, and it's an emerging area in engineering and consulting. It is innovation through the intersection of not just biology and technology, but biology with everything, and the possibilities are endless. You can't talk about biomimicry without a nod to its pioneer and founder, a fantastically talented woman named Janine Benyus. In 1997, she named the emerging practice area of biomimicry and popularised the term, and she's since founded a consulting firm called Biomimicry 3.8 and also the global non-profit Biomimicry Institute. She's a biologist and author and keynote speaker, and she's done several TED Talks on this subject and won numerous awards, including Time Magazine's Hero of the Environment Award. If you're interested in this topic, you can just search for her online and see her in action. So onto what biomimicry is. Nature has been around for over 3.8 billion years, and over this time has created ecosystems that are efficient, effective, and sustainable. Ecosystems that reuse and replenish resources and do not create waste. Species that live in harmony with those around them and create symbiotic relationships to further and develop progress. If nature has got it right for 3.8 billion years, then why do we need to reinvent? We have the biggest library for reference and inspiration all around us. By copying nature, we can solve some of our greatest design and engineering challenges in the future. So I'm going to go through a few examples of biomimicry in action. So looking at some of the photos here, if you can see the kingfisher nose diving into the water, you can see the streamlined shape and form of the kingfisher's beak as it dives into the water without so much of a ripple of disturbance on the surface. And this provided the thinking behind the design for the nose of the Japanese bullet train. It increased the speed of the train while increasing energy efficiency and reducing the noise impact. Another photo here from the starling's murmuration, which provides ideas for autonomous transportation planning, to the surface structure of the lotus flower leaf there on the bottom in the middle, which enables self-cleaning with rainwater, which is now used in some building surfaces. There are so many more fascinating examples that have helped humankind do things better. Ventilation systems inspired by termites, extreme weather building resilience inspired by the root networks of trees, harvesting water inspired by the Stenocara beetle, and wind turbines modelled by humpback whales. All of these learnings from nature have provided innovative design and engineering solutions that are better for the world because the ideas have come from what already works so well in the world around us. I want to finish up with a short video clip which shows how biomimicry can also help us address one of the greatest and most urgent issues of our time, climate change. This is how we can use carbon dioxide as a building resource.
A sustainable world has already been invented. It's right outside. How is this being done, and how can we mimic it? We think of CO2 as the poison of our era because we have such excess of it. But in the natural world, CO2 is a building block. Anything green that you see, from algae to trees, is composed of carbon dioxide. And anything hard in the ocean, like coral reefs or shells, they're made from dissolved CO2. Concrete, which is our largest building material, releases a ton of CO2 for every ton of concrete. 6 to 8% of all CO2 emissions are concrete. With coral reefs, it's the opposite. CO2 is sequestered in the reef. So there's a company called Calera that was started by a coral researcher. And he took the recipe from the coral reef, and now he takes CO2 from smokestacks, bubbles it through seawater to get the minerals, and out precipitates the raw material for cement, which is then used to make concrete. If we began to think of CO2 as a feedstock for our stuff, it might be a way to begin to use some of this excess CO2. To learn more about biomimicry, subscribe to the Wired channel.
I hope this overview of biomimicry inspires you all as much as it does for me by demonstrating how getting back to nature could really be the key to unlocking the future sustainable engineering solutions for tomorrow. Thank you.
Thank you so much, Zoe. That was really interesting. Finally, I'd like to introduce Alex Knight. Alex graduated as a mechanical engineer, like me, and is currently running a few jobs side by side. She's a visiting lecturer at Brunel University. She's founded her own business called STEMazing, which is dedicated to championing diversity and inclusion in engineering. And she works part-time as a technical director for Amy Strategic Consulting. Her work there spans engineering, data, and tech. She loves mentoring women in engineering and inspiring others about STEM. So I think she'll really enjoy this. A very warm welcome to you, Alex.
Thank you very much for having me. So what I want to talk about today is what it means to be an Industry 4.0 engineer. Now, the reason I love being an engineer is the variety of opportunity that opens up for us all. I've done a whole load of different things in my career so far, from working on submarines to electricity distribution to medical equipment. And now I work in my Amy job on the intersection of engineering and data science, which is really interesting. And I feel like this is the future of engineering. That's why I really wanted to talk to you about it today. And this can be encapsulated by what we call Industry 4.0. So first, let's talk about what is Industry 4.0. So you may have heard of the fourth industrial revolution, which is another way of saying Industry 4.0. This is the evolution from the first industrial revolution, which brought about mechanization with steam power and enabled things like the first factories. And then the second industrial revolution brought about the development of the assembly line and mass production with electrical energy. The third industrial revolution encompassed digitization, when we developed things like computers and using electronics. And now the fourth industrial revolution brings the networking of real and virtual worlds together using the Internet of Things, or IoT. Now this has enormous potential to transform the future of engineering. But what does it mean for us all? Now, we're not all going to be replaced with robots just yet, but the world around us is changing, and advances in technology is going to impact us in lots of ways. And engineers will be at the forefront of this. Engineers will be driving the development, the direction of the development, and all the possibilities that this opens up for us. So let's look at some examples. So for example, autonomous cars. Industry 4.0 developments allow engineers to use things like sensors and technology to drive our cars for us and drive them safer than we can. So not only will this in future, once this becomes mainstream, help reduce accidents, it will also allow us to be potentially more productive as people, because we won't have to drive our cars. We'll be able to do other things whilst traveling from A to B. Let's look at another example. Digital twins. So engineers are creating digital twins. A digital twin is a digital representation of a real thing. It's more than just a computer simulation, because the digital twin is connected remotely to the real thing using IoT sensors, like I mentioned earlier, Internet of Things. And this virtual and real thing can interact with each other in real time. So as engineers, we can monitor, analyze, and improve and understand our engineering assets much better, which allows us to make better decisions about what to do with them and how to manage them. Another example of how Industry 4.0 is impacting us is if you look at things like drones and robots that are going to be, already are being used, but will be used more, to do dangerous jobs that once would have involved humans. So for example, what you can see here is a drone looking at high voltage electricity lines. It allows us to do these jobs that as engineers we need to do, but put ourselves out of harm's way. Another example is using robots to go and look at bombs in battle lines. Another example of Industry 4.0 and what that's bringing us is 3D printing. Now, 3D printing or additive manufacturing is being talked about a lot at the moment because of the coronavirus pandemic, because people are making face shields, for example, for the NHS using 3D printing. We've seen this kind of thing in the medical field for a while now, things like printing prosthetics. But now engineers and scientists are even looking at developing techniques to print living cells, so printing beating hearts. Now that sounds incredible, but if you can print cells, just like you can print ink or you can print plastics, then think about the possibilities this opens up for us and the huge potential for improving human life. And of course, when we talk about Industry 4.0, we can't get away without talking about artificial intelligence. Now, there's a lot of excitement around incorporating artificial intelligence into our engineering world at the moment. Basically what this means is taking lots of data, more data than we could comprehend in our minds, and using computers to crunch that data and look at trends and analyze it in order to help us understand and make better decisions, or even potentially make decisions for us. We use this in a field called predictive analytics So it's essentially looking at historic trends and predicting the future, which is very clever and could be used in a whole host of different scenarios, and will definitely create very exciting times for us as engineers in the future. But we do have to be careful with all of this. We need to think about how to maximize the benefit of these advancing technologies, whilst also making sure we're doing it for the right reasons, that we're making sure that we're actually solving problems or improving existing things to make them better, cheaper, faster, safer. There has to be a good reason why we're implementing all of these technologies. And it has to be done in an ethical way and making sure that we're not unintentionally introducing other problems. So let's look at what some of the challenges might be for us as engineers. Now, one of the key challenges is integration. Now, all of this relies on the integration between the virtual and the real world. But integration points in any engineering system are the weakest points in the system. The sort of the edge bit where you want two things to interact. That's always a point of weakness. And Industry 4.0 is going to require significant integration from software, hardware, between the engineering and the technology and the data. These are all challenges that we as engineers and data scientists will have to tackle together. Another challenge will be ethics. This is a huge topic for discussion as we talk about Industry 4.0 and artificial intelligence. So as we move towards increasing digitization and greater innovation, what does this mean for the human race? How do we ensure development in all of these areas is ethical and is moving us forward as a human race? Making sure that as people, we're doing the right thing for people. So when you become a chartered engineer, you have to abide by what's called a code of conduct. And part of this is about working ethically as an engineer. Just because we can do something doesn't mean we should. We need to understand why we're doing it and consider the implications. And another key challenge is people. This all comes down to people, and we have a huge skills shortage of engineers. We don't have enough people pursuing STEM subjects and then going into engineering as a career. And as we create this future connected, integrated world, we're going to need more people who have those skills to bring the digital and the real world together. We need people with the skills to do this, and also the skills that can provide that overarching integration. But every year we don't have enough people choosing to become engineers, so we desperately need more. And that brings me on to my last slide. So what are the things that our future Industry 4.0 engineers need? So, to overcome the challenges I talked about in the previous slide, we need more people to train as engineers and as data scientists and help us build this future, this Industry 4.0 future, and open up all the possibilities that we talked about. But we need more people to study and pursue STEM subjects. So that's one of the core things. We also need people that are data and tech savvy. So as well as having the traditional foundation of engineering fundamentals, that's very, very important, we also want people that can combine this with tech savvy skills around data science and analytics. And we also want people who are not just experts in a siloed field, but are also able to have transferable skills like communication and collaboration, and are also able to see the big picture and see how all of these things are connected together, and be able to look at how do we derive maximum value from the system as a whole with all of these bits of the puzzle connected together. And of course, it's very important in this that we have diversity. We need diversity of skills because this brings different talents, different perspectives. We want the engineers that are going to be designing and creating these solutions to understand what the communities that will ultimately be using them need and want, so they can provide maximum benefit to those communities and to the world at large. And it's very important that we have a whole mix of different types of people working on our engineering problems to solve, so that we get those different perspectives. And one of the things we desperately need more of is gender diversity in engineering. So we need more girls to pursue STEM and go into engineering. And this is how we're going to take all of this potential that Industry 4.0 gives us to tackle all these global challenges that we have that have been mentioned a lot previously today, and be able to work together to make real change and improve our world through engineering. Thank you very much.
Thank you so much, Alex, and thanks to all our speakers for your presentations today. Now we're going to play you a short video while we put together the questions that you've all been sending in. That fantastic video was courtesy of the Royal Academy of Engineering as part of their This is Engineering campaign. Now for the questions you've been sending in. The first one I have here is from Amy. It's sent to Anusha, and she has asked, why do you think people, and specifically governments, refuse to make changes to reduce climate change or allow others to, when those changes would lead us to a better future?
That's an excellent question. I think it's about being complacent, about thinking like climate change is too far away. It's not happening now. The perception with the government is that there are other pressing matters. Just when they were really thinking hard about climate change, COVID-19 happened. But we as engineers are really pressing hard to them and saying that as COVID-19 has given us a lot of time for reflection and almost like a warning that it can happen, multiple hazards can happen. So we should have a green recovery when we come out of COVID-19. So the government is thinking about it, but of course there are conflicting pressures. But that's why Fridays for the Future, where all the kids were on streets, they really highlighted and it was high on the agenda. So I would say people, in fact, and I really commend people, and that includes especially the youth generation, is really forcing, because ultimately it's their world, it's their future generation's world. And we as engineers, that's exactly why I really, really enjoy my profession at the moment, is I as a person, as an engineer, am really pushing for our profession to be at the leading edge, because we have always designed for societies and we are in the best position for tackling these climate change impacts and working with all other professions. And this is a brilliant opportunity to create a more inclusive, safe, healthy society and tackle climate change. So I would say, in a nutshell, keep the pressure on. As a society, we have to keep talking about it. We need media, but we also need to keep banging on about it to governments so that they make climate change absolute number one priority. So I agree, it's not where it should be, but we have to keep at it. Thank you.
Thank you, Anusha. Thanks a lot. The next question is from Faith to Alex. It's actually a double-pronged question. The first is, what type of A levels or qualifications do you need to become an engineer? And the second is, once you're in it, at university or working, does engineering allow a good work-life balance?
Thanks, great questions. So the first part of the question, what subjects must you take for A level to enter into engineering? Well, typically we talk about maths and the sciences because having a foundation in those subjects gives you a really good grounding for going on to do engineering. However, having said that, it's not essential that you take those, and you can take other subjects and then sort of transfer into engineering. My husband, for example, is a chartered engineer, but he didn't do maths A level. But it made it a bit harder for him at university to sort of catch up, I suppose. Also, other A levels that are maybe giving you a different perspective, like languages, creative subjects, subjects that sort of expand your horizon outside of just maths and sciences is also very valuable. And of course, there are other ways to go into engineering, not just A levels, international baccalaureate, apprenticeship schemes. And now we've got degree apprenticeships where you can get, hands-on experience as an apprentice and also study for a degree part-time as well. So there are actually lots of different routes into engineering, and there's more advice on that if you look at websites like the IMechE or Engineering UK or Tomorrow's Engineers gives you good advice on that. And the second part of the question, does engineering allow a good work-life balance? That's really, I have to say, a great question, and it depends on, I suppose, your approach to life as well as the company you work in. I wouldn't say I had a particularly good work-life balance at one point in my career when I was just working really hard and as an engineering consultant traveling all over the place. But since having children, I have made a real effort to try and get a better balance. And now I work part-time for Amy, an engineering consultancy company, and which allows me to do the other things in life that I really want to do, not only spend more time with my children, but also do lots of volunteering that I do and STEM outreach. So it is possible. I would just say you have to decide what you want your work-life balance to be and ask for it. Thank you.
Fantastic. Thanks, Alex. The next question I have here is for Georgina. What are your engineers doing to make sure the infrastructure providing everyone with water is sound and will last long into the future? So a bit of a technical question from Amy for you.
No, that's good. Thank you very much. You may remember the slide I put up there about the 4 R's and looking ahead to the future. So we have a number of engineers, a different variety of engineers within the business, and what we're looking at is obviously planning for the future. So planning not just for the next 5 years, but the next 25 years to look at where we need to get water from, more water resources, and then how we would store that water before then treating it and delivering it to customers. And obviously we're limited on space. So especially in London, we're looking at dividing up all the assets we've got at the moment into like set areas or systems that we can look to ensure that we're using them to their maximum capability, and they're not just relying on one particular treatment works to treat one particular part of, say, London, where if it was to fail, we could have a serious issue, for example, with supplying water to the City of London. So we're looking at the options there for making our systems more resilient than we have, but also planning for the future. And then in terms of the actual assets themselves, we have to make sure that they don't just meet the standards of now, but we're looking to design for the future temperature rises, future climate change, changes in ground conditions, etc. And thinking of all the standards we need to ensure that we maintain our assets for at least the next 60, 100 years where possible. So lots to think about. I could go on, I appreciate we're probably short on time, but in terms of making sure water is sound, we obviously have very high quality levels we need to ensure we meet. And these will only get tougher as years go on. So we're planning for the future and building assets where we need to whilst making the most of what we've already got.
Thank
Super.
you.
Thank you, Georgina. Next question is from Eleanor for Zoe. Zoe, what subjects and skills are required in environmental engineering? And I'm aware you can be quite loose with this, considering you went through the environmental sciences route to begin with. So that's for you.
Oh, yes. Yeah, I'm not I don't have the traditional engineering background, so maybe you can offer a different perspective. I would say from an I studied environmental science at university, so for me the sciences and geographies were always an area of interest, and I think that served me quite well with that background going into an environmental science degree. But then as we sort of broaden out to sustainability, as you can probably tell from all of the presentations you heard today, sustainability is so all-encompassing that really I don't think there is a sort of, it isn't very black and white in terms of there's one path forward. I think to move into a sustainability focused career, there's a lot of different subjects, and in fact that variety could probably serve you well. I think if I think back at my environmental science degree, we did economics modules, we did law modules, geology, geography, some of the other sciences, some maths. So it's really a very varied subject, and for me that suits me well because I'm happiest when I'm learning across the board and lots of different things rather than being sort of pigeonholed into one actual discrete discipline.
Thank you so much, Zoe. The next one, I really like this question. It's slightly controversial, but I'm going to pose it to Laura. From Faith, which type of engineering do you think is the most creative branch?
Thanks for that question. That's a tough one. I think all engineering is creative. There are so many different disciplines out there, so it's not just what you would normally think. So we've had civil engineering mentioned, we've had aerospace, we've had water engineering, but within all of that, there's lots of different disciplines within there too, and it's very difficult just to pick one because, all engineering is creative, and it's one of those transferable skills that Alex was talking about in her presentation. Every discipline within engineering requires an amount of creative thinking, because ultimately engineering is solving problems, and to be able to solve those problems, you need that creative thinking, you need that creative space as well. So I'm sorry there's not one answer I can provide, but if I'm going to be biased, it's going to be aerospace.
I think I saw that one coming. I'm going to put this next one to Alex. It's from Robin, and she wants to know, she says, as a 12-year-old girl, what is the most important thing for me to do to follow a career in engineering?
Oh, fantastic. I would say stay curious, ask lots of questions from people around you, try and understand why and how things are the way they are. So when you're out and about, ask, people that your school teachers or people that you do clubs with, why things are the way they are and how things work. And never doubt yourself. I love this quote that asking questions shows your desire to learn more. It doesn't show your lack of understanding of what you already know. So really keep asking questions. And wherever you can, if you see people, maybe your parents' friends or school teachers that have got careers in STEM, ask them how they got there. And everybody has a different story and a different path into STEM. So just keep asking lots of questions and be curious. And if you can, join STEM clubs. And certainly there's loads of STEM stuff online at the moment. STEM Learning UK is publishing loads of activities you can do. The IMechE of publishing resources. So just have a go at those, and just be curious and test things, and have confidence in yourself, and don't worry if you make mistakes and fail, because that's what we all do, and we get there in the end.
That's
I
a
hope
lovely
that answered
answer.
it.
Really nice one, Alex. Thank you. The next one is from Anthony. I'm going to put this one to Laura because I think this will be particularly interesting. We've heard a lot from speakers today about sustainability. So Anthony's question is, do you think humanity's dreams of going into space, colonizing other planets, and all of that can go hand in hand with the way we can build a greener, better planet here? Are these two angles of engineering consistent with one another? That's for you, Laura.
Oh, that's an interesting question. I think so. There's two sides to this. I think that yes, I think it does go hand in hand because I think we can learn a lot about our own planet when we go and when we start thinking about colonizing other planets. I think, to be honest, that's a long way off. But when we start looking at the planets that maybe are habitable, potentially for holidays and for commercial space travel, we need to start. Well, we need to really think about how we can create Earth and make Earth a better place to live as well. So yes, I think that by looking at colonizing is such a strange word. By looking at other planets, we can create a greener, better Earth.
Thank you, Laura. Thanks a lot. So now we've got one last question from Ruby, and it's such a lovely one. I think I'm going to ask all the speakers to give their answer one by one, just in one line. What is your biggest wish for engineering? So let's start with Anusha.
Right, what a lovely question indeed. My biggest wish is I want to see a really genuinely inclusive engineering workforce. And I would like to see women at the forefront of it, because I think more than anything else, this world now needs more kindness, empathy, and I would want those women to teach men the same qualities as well. Not saying some of the men don't have it, but we need more empathy, kindness. I think once we have those attributes, we all can tackle any global challenge that comes our way. Thank you.
Thank you. Georgina, your biggest wish for engineering?
Well, really building on what Anusha's just said, I think it's that recognition that it's not perhaps the view that people may have of it, and that the importance we can provide for protecting the environment for the future and working together. So yeah, I think it's about ensuring that we get the sort of bring the engineering to the forefront for what it can do for the future, and it's not just all about building sites, and ensuring that people recognise the wider discipline and what we can bring to help society. That's really key for me, is helping people, giving back.
Thank you, Georgina. Laura?
So I think, one of my biggest wishes for engineering is for society to appreciate how great engineering is for everyone, and for it to happen. I talk about collaboration quite a bit. So for people to recognise that you can't do something on your own, and we have to pull on each other for support, for help, and to solve the problems that we have today and the future. That was my biggest wish.
Laura. Thank you. Zoe?
I would say for engineers to be really at the heart of a green recovery following this pandemic, and ensuring that all of our contributions result in a sustainable future.
That's a sentiment shared, Zoe. Thank you. And finally, Alex.
My biggest wish for engineering is that more young people aspire to be engineers. We don't have enough engineers, full stop, but we particularly don't have enough women in engineering, with only 12% of the UK workforce in engineering being women. We desperately need more girls to choose STEM and pursue STEM and go into engineering. This is the only way I think we're going to get truly diverse, relevant solutions that we need to all of these global challenges we've talked about today. So my biggest wish for engineering is that more young people, and particularly girls, aspire to be engineers.
Completely agree. Thank you, Alex. I'm afraid that's all the questions we have time for today. Please check out our SheCanEngineer YouTube channel tomorrow at 3 p.m., where our very own Alex Knight will be running an interactive workshop. We'll circulate a link later on today after this webinar, but in the meantime, on behalf of SheCanEngineer, I'd like to give a big thank you to our speakers, our supporting engineering institutions, the events team at the IMechE, and most of all, you, our audience. Thank you for joining us today to celebrate the achievements of just a few of the many brilliant women in engineering. Have a lovely day.